Okay, welcome to Algebra 2, Semester 2, Unit 7a. We will be solving rational expressions in this unit. This is just the prep and chapter 5.4 just to prepare you for doing this unit. So, in preparation, I just want to review once again factoring with you. So, if we are solving this problem, m squared plus 4m equals 21. We would pull the 21 over or get rid of it on that side and set it equal to 0. By doing that, now we can break it down into our binomial factors. Taking the shortcut, because there's a 1 on the leading coefficient, we can simply put m, and now we think of the two factors of negative 21, so one's got to be negative, one's got to be positive, that have a difference of 4. That would be 7 and 3, so the 7 will carry the value of that 4, carry that sign, because it's the farthest one from 0. So now if we say that these two items multiplied to equal 0, then one of those two items has to be 0. So m minus 3 equals 0 when m equals 3. m plus 7 equals 0 when m equals negative 7. Go to my Algebra 1 Semester 2 or my Algebra 2 to Semester 1 on factoring if you need a little bit more in-depth coverage of this. Here we have a binomial. This is a perfect square. X times x is x squared. This is a perfect square. 8 times 8 is 64, and it's a difference. So we go immediately into our sum and difference factoring. X, 8, and 8. So there's the final answer there. On this one, this is a perfect trinomial square. The way that I can tell that is that that is a perfect square. It's 12 times 12, and 12 times 12 equals 144, and 12 plus 12 equals 24. So that tells me that I just need to simply write it once. We take the minus from there, take the 12, and we square it. Okay? Come down to the next one. We see that it is a difference of two squares. So we immediately go into our plus minus shortcut. X squared, the root is x. 169, the root is 13. Do not forget that there's a y squared there, so you need to bring down a y and a y. So that one's done. Now on this one, it's not a difference of two squares, so we go to the GCF factoring. What's the largest number that would go into 18 and 32? I believe it's 2. 2 will go into 18 9 times. 2 will go into 32 16 times. Now if you look at that, you might say, wait a minute, that looks like difference of two squares. You're exactly right. So we would go to a plus minus pattern here. Don't forget to bring down this 2 here that was a factor. The root of 9 is 3. The root of 16n squared is 4n. And there's our final factors. So always be on the lookout for GCFs, for difference of two squares, for perfect trinomial squares, whatever it might be. Now I look at this one. That is a perfect square, so this might be a perfect trinomial square. That would be 10 times 10. It does happen to occur that 10 plus 10 is 20. So we have n, bring down the sign from that middle term, and bring down the factor, and square it. Okay? If you were to play the x game on this, it would still come out correct. So don't feel that you have to take that shortcut. Okay, this is factoring 4 terms. X will come out of there. X squared will actually come out of there. When I take the smallest exponent, that will leave me with x minus 3. Come over here, x minus 3. What times x equals 9x? That would be a positive 9. So now we factor out our x minus 3. What we have left is an x squared plus 9. Now you might say, oh, that's a difference of two squares. Be careful, that's a sum of two squares. And we don't need to break that down any further. Okay, next one. 4 terms again, go 2 by 2. So the lowest exponent on my variable is x squared again. So now we have x plus 6. We write that over here, x plus 6. What multiplies by x to get negative 6x? That would be a negative 6. So now we have x plus 6, that we factor out. And what we have left is x squared minus 6, which is not a difference of two squares because 6 is not a perfect square. Last one, it's not 4 terms. It does have a GCF, so I would suggest that we pull the GCF out first. That would be 4x that we can pull out to the front. 4x times x squared will give us 4x cubed. 4x times negative 48x squared would be a negative 12x. 4x times, how many times does it go in there? You might have to write it off to the side to figure that out. Please don't grab a calculator, especially if you haven't passed your standardized test. Get used to doing the math. 4 goes into 12 3 times. Subtract. We bring down the 8. 4 goes into 8 2 times. Now we look at this. It's not a perfect trinomial square because 32 is not a perfect square. So we go ahead and we factor this down, if we can, and we say there's no number out here, it's just a 1, so we can put the x right there. We know that it's got to be a positive 32, so the signs will be the same. Because it's a negative in here, they'll both be negative. We ask ourselves, what two numbers add to be 12 and multiply to be 32? That would be 8 and 4. Bring down our 4x, and you have factored it completely. Okay? Now we have something that we really did in depth in the first semester of this class, and I just want to remind you of it. The sum of cubes would be a cubed plus b cubed. And if you remember right, we went through a detailed explanation of how to break that down and factor it. And the final factor form was a plus b, a squared, minus ab plus b squared. Okay? So the way that you can just use that formula is when you see a problem, let's say we have 8x cubed plus 125. When you see that, you should immediately say, oh, I remember these numbers. They were in my list of cubes Mrs. Kane told me to memorize. When you see that, break them down to their roots. So it's 2x cubed plus 5 cubed. And now you can look exactly at this, and you can see my a value is 2x, my b value is 5, and just follow that 2x is a, 2x, 5 is b, and plug it right in there. 2x squared would be 4x squared minus 5 times 2x would be 10x, and then b squared would be 5 times 5 or 25. So that's how we use that. It makes it kind of a shortcut. And the formula is not too bad to memorize. Here's the only difference between it and the difference of two cubes is you memorize the exact same formula, except for that this time, because the minus is in place, the minus comes to the front. So it's a minus b, and now all of these are positive in this one. A squared plus ab plus b squared. Okay, so give you an example of that one. Let's say that we have 27m cubed minus 1. Look at that and I'd say, oh, that's a perfect cube, that's a perfect cube. 1's always perfect. And so I can go straight to this after I break them into my cube root. So I have 3m cubed minus 1 cubed. Now that's my a value, that's my b value. So I look over here and it's a difference of 2 cubes. So I have 3m minus 1. I know my first term is my a value squared, so it's 3m squared. I'm going to show this just working it out a little bit better than the last time. Then I've got a times b, 3m times 1 plus 3m. And then I have b squared, which is 1 squared. So 3m squared, that would become 9m squared. So my final answer, I wouldn't need to put the square on the 1, would be 3m minus 1 times 9m squared plus 3m plus 1. Okay, that's just kind of a refresher on factoring. Here I'm going to just refresh you on, it looks like multiplying, distributing, and then adding like terms. So 9x times x plus 4 would be 9x squared plus 36x. Negative 6 times x would be a negative 6x. And negative 6 times 4 would be a negative 24. So now we combine those. 9x squared plus 30x minus 24. Okay. I am guessing that that's all the further that I wanted you to go. I don't see my instructions for that. I'm going to take it that that's where we stop. I'll tell you in class if there's something else that I wanted you to do. Okay, on this one, distribute. 5y squared times y will be 5y cubed. 5y squared times negative 2 would be a negative 10y squared. 3 times 2 will be 6. 3 times negative y will be negative 3y. The only thing that you need to do on top of that, sorry, my phone's ringing. I'm just going to ignore it. The only thing that you also need to do here is to put these in order to write it in standard form. So it would be 5y cubed minus 10y squared minus 3y plus 6. I'm sorry. Now you're going to hear my son on the answering machine. So anyway, so here is the final answer in standard form. Next one. Because I don't see anything else indicating what I'm doing, I apologize, I don't have directions on here. I am thinking that I am to be factoring this one. So probably the directions were to simplify, and that would be correct up there, that we've distributed and added them together. So on this one it would be correct to factor it out. What number goes into 12 and 18 is 6. The variable would be x, because you take the lowest exponent. So we get 6x goes into 12x squared, 2x times. 6x goes into 18x, 3 times. So we're done right there. This one, let's go ahead and distribute and then add like terms. 2y squared times y would be 2y cubed. 2y squared times negative 2 is negative 4y squared. 4 times 2 is 8. 4 times negative y is negative 4y. Now we need to put them in standard form, which is descending order on the exponents. It goes 3, 2, 1 on your exponents, on your variables. That's how standard form looks, and it is the proper way to write them. Okay, factor the common expression. The leading coefficient of each factor must be a positive number. Okay, so this time they are wanting us to factor these. So we have 9y squared times y is 9y cubed. 9y squared minus 13 is a negative 9 times 13, 27, 19, 11, negative 117 y squared. 8 times 13 is a positive 8 times. Well, we know that 9 was 117, so we could take 13 from that and get positive 104. Let's double check that. 24, yeah, that would be right. 8 times negative y is negative 8y. Okay, so we have 9y cubed minus 117y squared minus 8y plus 104. Now that's written in standard form. We can check to see if we can factor out of that. We know that 9y squared goes into each. In fact, that's kind of silly that I just did that, because we can look over here and see what was happening. In order to break that down, oh gosh, I must really be tired. We can go back. We'll do it this way. We take the 9y squared out. We're going to get the y minus 13. Now we come over here, we have y minus 13. What multiplies to get to negative 8y would be a negative 8. So we get 9y squared minus 8 as one set of binomial factor, and the other one is y minus 13. Now, I wasn't really thinking about what the directions were. We could have looked at it right here. Here's the shorter cut to us, is we can see that y minus 13 is just backwards in order and opposite in sign from 13 minus y. So we could have gone right here to this step, 9y squared y minus 13, and change this to a y minus 13. In doing that, we have to factor out a negative 1, because it was a negative y and we made it a positive y. It was a positive 13, we made it a negative 13, so we factor out a negative 1. Negative 1 times 8 is 8. So that would have been a much quicker way to do it. Either way is correct. Okay, let's see if I can wake up here. Factor out from this, it says to factor completely, so we'll have to double check things and make sure that we've got everything simplified. First thing I'd factor out is 5. I would take my lowest exponent on my variable. 5h squared goes into 45h squared, 9h squared times. 5h squared goes into negative 5h squared, negative 1. Now if we look at that, that's a difference of 2 squares. That's our plus minus pattern. So the root of 9h squared is 3h. The root of 1 is 1. 3h and 1. And there's all of our factors. We can't go any further. Okay? If you need to review the factoring on previous classes, I am kind of hurrying through this one. If we look at this, it's a difference of 2 squares. So we would have x squared minus 7 and x squared plus 7. Thank you very much for joining me for this lesson. We'll see you tomorrow in class.